Okay, let's finish up example 3 and 4, determining the domain and range of a graph of a situation. So this graph shows a number of fishing boats N anchored in an inlet in the Queen Charlotte Islands as a function of time t. So if you look at the x-axis, it's representing with t for time, and n on the y-axis for the number of boats. So A says identify the dependent and the independent variable, justify your choices. So for A, we have our independent variable is always along the x-axis. And so there's two different ways that we know what it is in this case. It's always along the x-axis, first of all. Second of all, it's always time. If you're ever working with time, it's always going to be the independent variable because everything else depends on time. Time doesn't stop, doesn't depend on anything else, it just keeps going and going. So the dependent variable then is the number of boats. The number of boats depends on what time it is. For B, why are the points on the graph not connected? So this is what we call discrete data. Because we're talking about the number of objects of something, so that's why we're talking about the number of boats. We can't have half a boat, so there's just no way that we can connect these dots. When we connect these dots, we imply that there's going to be half a boat or a quarter of a boat, which doesn't make any sense. So it's called discrete data. That's why the lines aren't connected. C, determine the domain and range. So I kind of like discrete data when we work with domain and range because we just get to list the numbers given. Okay, so for domain, I just list all of the numbers that it touches on the x-axis. So my first number here is 9 a.m. Then 10 a.m. And then 11, 12, 1, 2, 3, 4. So I'm just going to keep writing 11, 12, and we're using a 24-hour clock, so that's 1300, 1400, 1500, 1600, which is 4 o'clock, and then I close a curly bracket. That's it for discrete data for domain. And range is the same, I just list the numbers. So my first, and typically we go from the smallest number to the largest number. So if this is 4, this would become 6 because these 2 points land at 6, so that's 6. This one here is 8. These are 10. Here is 11. 15. And 25. That's it. Okay, I'm going to let you do 2. And we are going to try example 4. Determining the domain values and range values from the graph of a function. So here's the graph of a function, negative 3x plus 7. A, determine the range value when the domain value is negative 2. So determine the range value. The range value means your y value. So they're asking you what is y? And the domain is x equals. So we're saying x equals negative 2. What does y equal? Okay, that's all they're asking. So x equals negative 2. What does y equal? So when x is equal to negative 2, here's negative 2. I just follow it up. And y would be, here's 12, 14, y would be 13. There we go. And B, determine the domain value. So what does x equal? When the range value, that's your y, is 4. So y is equal to 4. What does x equal? So when y is 4, that's on my vertical axis. Here's 4, and that's what y will be, which is 1. Or sorry, x. Oops. X equals 1. That's it. Okay, the next question is very, very similar, so I'm going to get you to try that on your own as well.